let's construct inverse cosine just like we did inverse sine. So we are going to start out by sketching a graph of cosine, and hopefully this graph is familiar. It looks something like this. It tops out at 1, the bottom is at -1, and it goes through one complete cycle after 2 pi. Okay, now this graph is not one-to-one because if you sketch, because there are horizontal lines that intersect the graph more than once. So to produce inverse cosine, we have to actually throw away most of the graph of cosine. And the part of the graph that we'll keep, remember we want to keep as much of the graph as possible. So if we keep this first initial point and continue to the right for a little ways, the red part is one-to-one, so we can keep going. It's still one-to-one, so we can keep going. When we get to this bottom point, if we went any further, it wouldn't be one-to-one anymore. So now we have to stop. This interval of input values from 0 up to pi is the largest interval that we can use to define inverse cosine. This isn't the only interval you can use. You could use from -pi to 0 or from pi to 2 pi, but this is the standard choice for constructing inverse cosine. Okay, now that we have chosen the part of the graph of cosine that we're going to keep, let's sketch the graph of inverse cosine. Let's do that over here. So this was cosine. Now let's sketch inverse cosine. Okay, so the domain of inverse, well, let's sketch the graph before we talk about domain. So let's take some points on the graph of cosine. So this first point is 0, 1. Remember, we're going to reflect across the line y equals x, which interchanges coordinates on points. So 0, 1 gets reflected down to 1, 0. This point way over here on the right is pi, -1. And when you switch x and y coordinates on that, you get -1, pi. So that's way up here. Let's do one more point. How about this middle point where the graph of cosine crosses the horizontal axis? That's at pi over 2, 0. And when you switch x and y coordinates, you get 0, pi over 2. And that's going to be right here. All right, now if you imagine sketching this red graph of cosine on a piece of transparent paper and then flipping it across this diagonal line, what you'll see is that this rightwards, downwards, then rightwards motion of the graph of cosine gets flipped to an upwards, leftwards, upwards kind of motion. And that's going to look like this: upwards, leftwards, upwards. So there's the graph of inverse cosine. Now that we have this graph, we can write down the domain of this inverse cosine function. You can see it's from -1 to 1. That's just all of the input values where the graph exists. The range of inverse cosine is all of the output values that it produces, and that's from 0 to pi. Notice that this is the domain of inverse cosine is also the range of cosine, and the range of inverse cosine is also the restricted domain of cosine. So again, we find that inverse functions just switch inputs and outputs, and so they also switch domain and range. All right, finally, let's evaluate these two values for inverse cosine. So inverse cosine of -1/2. If you can't see how to evaluate this immediately, give this value a name. We could call it theta. Switch back to the original trig function by switching inputs and outputs. If inverse cosine of minus a half is theta, then cosine of theta is minus a half. So we're looking for some angle whose cosine is minus a half. So sketch yourself a most important diagram. We're on a unit, so we can be on a unit circle here. We want cosine of theta to be minus a half. On a unit circle, cosine is talking about x coordinates, so we want an x coordinate of minus a half. And also, the restricted domain of cosine is from 0 to pi, so this top semicircle. So whatever angle we draw that has cosine minus a half, it has to be in this top semicircle here. And looks like it's this angle. And hopefully this diagram will remind you that we actually know an angle whose cosine is minus a half. It's 2 pi over 3. And if you want to check, you can calculate cosine of 2 pi over 3, either by finding a reference angle or just remembering your unit circle. It is indeed minus a half, so this value for theta is correct. So inverse cosine of minus a half is 2 pi over 3. Okay, now let's do inverse cosine of 0. All right, so can you think of an angle who's in the top semicircle whose cosine is 0? You're right, it's pi over 2. Just to draw the sketch. So in a unit circle here, we want our x coordinate to be 0 because cosine, we're looking for the output of cosine to be 0. That is here. And on the top semicircle, there's only one angle that puts you at the top of the unit circle or the bottom. It's at the top, and this angle is pi over 2. All right, so that's inverse cosine. Of course, there's also inverse tangent, inverse secant, inverse cosecant, and inverse cotangent. But it turns out inverse tangent is the only one that's really worth knowing the graph of, so that's what we'll have a look at next.